Hi everyone. My name is Iván Ávalos. I'm mostly working on the mobile wallets for GNU Taler. So let me get there. So first of all, money is so overrated. So it's like everyone is talking about it all the time. It's kind of repetitive. It's getting a bit repetitive how everything is just basically doing the same things in different ways using different technologies. But in the end, it's just payments, getting money from one person to another person. And yes, there are very exciting ways to do it, but otherwise it's just we need to think a bit farther from that, a bit beyond what money is, because I mean, it's everywhere. It's everywhere, even in the soup. So yeah. Unfortunately, GNU Taler can do much more. So, but first of all, you need to understand what is Taler. So Taler is like cash, but digital. So Taler is a payment system. It is not a cryptocurrency. It is not any kind of a new way of. It's just digital cash. And for that, I can use my wallet to explain to you how it works. So what happens with real cash, physical cash? So I go to the ATM, clink, 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 and then I withdraw the money. So I get the money. So then, does it have my name in it? It's just any regular bill. It doesn't have my identity. You don't know it came from me, or I withdrew it. It's just any other. So then I go to the shop, I pay, I get my coffee or whatever, and then it goes from hand to hand multiple times. I don't know, and then some person goes and then deposits into the ATM. And then clink, clink, and then it's now paid. But if you notice, there's no history, there's no database of what am I using my money for? What am I doing with my money? It's just going from hand to hand, and at some point there's no trace of where I spend my money on. And the shop doesn't know exactly who the money comes from either, unless the merchant knows me personally or something, but banks don't have this record with cash. So why should it be any different when you are paying something with your credit card? Why should this anonymity not be preserved? First of all, because there are interests on your personal data. There are interests on controlling some of the things that you do and knowing exactly everything, everywhere you are. There's a lot of interest in that. So unfortunately, so Taler is trying to do that in a way that you can use your phone to pay in an anonymous way similar to cash, but with all the conveniences that come with doing it with your phone and having the internet as the portal to get your money from one point to another, which is a very large thing. So you can pay on internet, you can pay in websites, microtransactions, you can buy an article from a newspaper very easily without your cash is already on your wallet. So you don't have to do any login, any two-factor authentication of all of that things that usually take a lot of time, and by that time you're not longer interested in the article that you were buying. So yeah, that's kind of what Taler is trying to achieve. Pay privately and securely, not a new currency, nor is it married to any. But here's the thing. It's completely free software. Everything from top to bottom, all the components in GNU Taler are free software, licensed under the GPL or LGPL. No, GPL Affero for the server parts. So you have the choice as to have your own community run its own payment system. You can even have your own regional currency that works for your community only. And we already have cases of some people doing that and using Taler for that, such as Netzbon in Switzerland. So yes, and also furthermore, we are from the aligned with the GNU project. So yes. So now I will give you an overview of the components of the system. So Taler is made of many services that work together in order to achieve the transfer from A to B, or and many more. But I will talk about how you have two banks. And banking usually works with transfers, with money transfers from one bank to another using very sometimes standardized protocols to allow both banks to understand each other and send money from one to another. So Taler leverages these protocols that you have in banking, and it uses them to implement the exchange component. So the exchange, what it does is basically it takes money from one bank account and then it creates coins, digital coins that correspond to the money that you have in your bank account, the exchange's bank account at least. So then when you withdraw the coins, you get a blinded version of those coins that doesn't have your identity, because I will explain a bit later how it works. So then you have those anonymous coins, they don't have your identity, and you use them to pay. So then I send them to the merchant, and then the merchant will do the opposite process. It will exchange those coins for money in the bank account of the recipient. So when that happens, a wire transfer will occur between the customer and the merchant bank, and then you will have the money in a way that is untraceable. So I will explain a bit more in detail how. But then we talking about the money is borrowing, money this, money that. Taler now supports something called tokens. So what's a token? First, I will explain what's a token family, which is a template for tokens. And so you have a key. So, well, a token is basically a digital representation of something that can be with different semantics. I will actually. It's okay. So introducing tokens first, actually. So a token is a key pair that represents an object that can change the semantics of an order. So what happens when you're doing a payment? When you're doing a payment, you have the option to pay with a certain amount, and that amount is represented by coins, blinded coins. But then a token can allow you to express more than just an amount. So you can, for example, have subscriptions, discounts, you have coupons, you can have loyalty cards, event tickets, donation tax receipts, company assets. You can represent anything in a token that is not tied to any currency at all. It's just some value that you allow, some meaning that you add to the order. So for example, a subscription. So you have a wait a minute. I think this is a bit shuffled. So I'll give you a bit of background. I'm doing it a bit backwards, but I will get to all the concepts that we need. So first of all, Taler is built on top of a cryptographic concept called blind signatures. So what's a blind signature? You have a message that you will. So here's the analogy to explain it. So this is what we use. It's something similar to what happens if you want someone else to sign a document for you without that person actually reading the contents of the document. So how do you do that cryptographically? Well, there's a lot of math involved, but the way it works is something analogous to how you would put like a document into a folder, into an envelope with carbon paper, which can allow you to trace trace back to the paper behind. So then you put it in the folder, you send it to the signer, and the signer will sign the envelope. It will never open the envelope. It will just sign it, and then you get the signed envelope from the signer, and then you open it, and then it's transcribed the signature into. It printed the signature, but the signer never knew what were the contents. So the way it works with coins is that every coin in GNU Taler has a different envelope, a different key pair that it can allow you to distinguish between the denominations. So for example, 1 euro, 2 euros, 5 euros, 10 euros. So you have a different envelope for each of the coins. And then you assemble those coins into, you select a combination that gives you a certain amount. And then that's what you do this process. And you get the signed coins that you can spend with the merchant. But by then, they no longer have your identity because the merchant never knew exactly which coin it signed. It just knows it's valid. It knows it was issued by the exchange itself. So this is what we use for coins. So now, if we want to apply this the same for tokens, that's where the magic comes. So that's where we go to actually introducing the token families, which are basically the coins, but without a value. It's just so for example, let's say I have an order that for a certain product, and I want to offer a discount. So I will have a token which is a discount coupon, but I want this discount to be applied many times. I don't want just one coupon, but I want like a template to produce the 20% discount coupons. So instead of a coin, you will have a key pair for every one of those coupons that the shop defines. So it will have a name, it will have a description, and a kind. So this kind, in this case, can be a discount or a subscription. And you will also have like from when to when it's valid, and the duration of for subscriptions, maybe a month. And the granularity, which allows you to round to a month or to a day or to whatever your use case needs. So now, with the token family, we can print many tokens. And every token will be its own key pair. And we can, whenever we want to use those tokens to pay an order, we will blind them before we send them to the merchant. We will do the envelope thing that I explained, and then the merchant will give me the signed tokens and it will round down the validity, so I cannot use it after a certain date. So yeah, this all came from the design document that we drafted originally to explain how this would work. I will explain a bit more in details what was the final implementation of the design. And also the bachelor's thesis from Christian Blethlers from 2024, designing and implementing token-based subscriptions and discounts in GNU Taler. Okay, so let's go to the API. So this is the API of the merchant, the software that the merchant will run in order to accept the payments. So around each payment in GNU Taler, we have what we call contract terms. So the contract terms is an object, a JSON object that is issued and signed by the merchant software that contains all the attributes relevant to the order that the clients will pay. So this is what we can use to say, okay, you will get this product and it will cost this much, and the order, you can pay it until this time, and I accept this exchange to receive the money from you. And these wire methods, you can encode many things here. But the thing is, this is the way we are doing it right now. It's very limited. It only allows you to specify an amount. So like you have this product, you want to buy it, and then you have this amount, and that's it. You will pay this amount. Okay, but that's very simple, and it doesn't allow you more than just setting the price. So based around the concept of tokens and token families, we evolved the contract terms into contract terms version 1. where we can actually specify a certain amount of choices that the user can pay with based on the semantics that the merchant defines. I will explain a bit more how this would be used in an example, but for now we have the choices, and we have token families already embedded. All the keys that the merchant will use for the token families so that the wallet can prepare the envelopes, those are already in the contract when you get it from the merchant. So the wallets have everything that they need to decide whether they can pay or not the order, and then prepare the payment. So then, what's in a payment choice? So a payment choice has an amount, a maximum fee that is willing to cover from the exchange, and it has what is relevant is that it has inputs and outputs. So it's not just okay, it will cost this much if you pay with this choice, but we also need that you pay with this token, and we will give you this token in return, or you can have any amount of combinations, and that's where the semantic comes from. And then you can get tokens as an input and tokens as an output, and then you can have different trust models. So other merchants cannot steal your subscription by claiming to be the other merchant, and now I have your Netflix subscription or whatever. So there are many trust models to make the wallet alert the users when this is happening. And you also have the keys, where the validity periods are encoded, so the keys will not be accepted after a certain date by the merchant. So the way you would use this is basically, let's say I have this at least for discounts. Let's say I have this product. There's one choice. One choice is you will pay the full price. And there's another choice where if you have a discount coupon of 20% off, then the price for that choice will be less. So, but only if you have the coupon. So then if you do some purchase and then you get a coupon from the merchant, the next purchase you can use that coupon to discount the price of the product and you pay less. So that's for discounts. So for subscriptions, is basically you can either pay the price of the newspaper article, or you can buy a subscription so you have unlimited access for 1 month. And then the next time you want to read an article, you pay with the subscription token. And then you get another one back to refresh the access, and you pay nothing actually. So because it's already in the subscription token that you got from the merchant. So now let's see what are the requirements. What were the requirements for this? So first of all, you need to do a token selection. So you have a certain amount of tokens stored in your wallet that you got from the merchant. And those can be from different token families, 20% off, or 1 month of subscription. You have different kinds that the merchant can issue, certain tickets that the merchant can give you. Then you also have the validity periods, which is from when to when the merchant will accept it. And you will also have where that coupon comes from. So whenever you try to use it with another merchant, it will say, hey, they may be trying to steal your subscription, whatever. And you should not, we will actually sometimes not even allow you to pay because it's a security fault. So then the UI should present all those choices to the user. And it should pre-select the cheapest payable choice so that you don't have to search for the cheapest. You already have it there. It's more of a UX thing. And also, paying an order with a subscription token should not require confirmation. You don't want the UI to ask you whether you want to spend your subscription token, because in the end the merchant will give you another one. So it's free. It doesn't cost you anything. It's just access. And also you need to list and manage the stored tokens so you can know what are the discount coupons that you have stored in your wallet. Also for speed efficiency, the slates should be pre-generated. So whenever you pay, they are already. You don't have to wait for all the slates, the things to be generated. So the database. How is the database structured? This is a fun fact. So how do we call a coin before it was printed? It's actually called a slate, a planchet. So that's how you would call the metal thing that the banks will imprint into a coin. So before the coin is signed and by the merchant, by the exchange, it's called a planchet. And then when the wallet has the signatures for that coin, it will turn into a coin. So we were trying to come with an analogous. What is before the token? And we were discussing many different choices for a name, and we decided slate, because a slate is a blank slice of rock cut for use as a writing surface, which is like a kind of rock that you turn into like a whiteboard. And then I don't know how we arrived to that, but I think it's a name, just yes. So we have the slates in the wallet. Those are the ones that we generate before we actually get the signatures by the merchant. And then whenever we complete a payment with the tokens, and the merchant gives us tokens that we received from the purchase signed, then we store them into the wallet as tokens. And then you have the purchase, which already contains the choice, the index of the choice that the user confirmed. And then we have the Wallet Core API. So for a bit of context, Wallet Core is the software that is shared across the mobile wallets. So it's a multi-platform core that all the wallets use to implement the operations that allow you to pay and use the Taler system from your wallets, your mobile phone or your web browser extension. So instead of writing one for a platform, we just use one, and it has an API that you can use to communicate with it and do all the operations that you need. So of course, to support tokens, we need to add the support to the Wallet Core component. So we have we originally had the prepare pay for URI, which is the one that when you'll see a bit how it works in a minute. So prepare pay for URI, you get the Taler URI that encodes the details of the payment, and then you get it prepares the payment in the wallet, so you can show the information to the user. And then you confirm the payment, and like, yes, I want to pay this, and now the wallet starts all the operations that it needs for the payment. And you also have, but as part of this tokens implementations, there's this new get choices for payment, where you can get the information of whether you can pay each choice or not. So like, yes, I have this choice, I have enough tokens, I have enough balance, so I can pay this one. But this one, I don't have enough tokens, so I cannot pay it. So everything will be shown to the user in a way that the user can understand how what it can do and what it cannot be done. So we have the typing for this. The request is just the transaction ID. Then you have the result, which will have the choices. And there are a few kind of details here, like, for example, which one should be pre-selected and which ones should be automatically paid in case you have enough balance. So for example, a subscription, if you already have the subscription, you don't want the UI to like prompt you to pay, because it should do that automatically. It's free. So that's some of the considerations that had to be in the typing in order to enable the UI to work the way it should. So yes, we have all the things that I already explained. But now, how do you show that in the UI? So yes, I hope your necks are. So we have the choices there. We have the order information, the basic order information, and we have the choices that the user can pay. So the user can select the choice that it wants to pay. It will show you the information, what are the tokens that you are spending and what are the tokens that you are receiving from that purchase. So this was the original design by my colleague. And so this was the Android implementation. I will show you a live demonstration of this. So yes, this is how it turned out in the end. So I will show you the demonstration. And you can actually also test it with your phones. Hopefully. So, but first, if you're a shop, you will want to add those subscription discounts and all of that, so you can use them for your clients, so your customers can use them to. You can give them to your customers, and the customers can use it to get discounts from you. So for that, we will go to the backend. So this is the software. This is like the software that the shop will be running. Taler is an open protocol. It doesn't need you to use our components, but if you want to use our components, this is the dashboard, the merchant back office, where you can manage your orders, your inventory, everything, including the token families. So here we have the token families. So you can add new ones. You can add your discount coupons and whatever you want to add here. So here we have the subscriptions for a blog, for a demo article shop that I will show you in a minute. So if you want to add a new one, you can add the name of the slug of the token family, and then whether it's a discount or a subscription, and then you can add the information, maybe 20% off or something. And then descriptions, you can write something here, and you can set the dates where this discount will be valid, and what's the rounding for that, and how much, in case of a subscription, it should be valid for. So this is like the things that the shop administrator should be responsible for. So now this is already configured for my demo, so no need to do it again. So now, first we install the Taler wallet. So there's this QR code which you can scan, which takes you to wallet.taler.net, where you can download the wallet for your platform. So there's a detail here. So F-Droid is a bit slow sometimes with the build. So right now we don't have the newest version of the wallet that supports token families. So you should, if you're trying this, you should, for Android, you should install the nightly APKs. So the latest nightly APK, it should be there in a link. You install it, and it's actually pretty quick. It's not very heavy. So don't download from F-Droid. And iOS not yet, doesn't support this yet. So only Android for now, and the nightly APKs. But soon it will be available also in F-Droid. So if you already scanned this QR code, now what you need to do is to withdraw test money. Because we have a currency, a toy currency called Kudos, or test Kudos for the test deployment. So it's toy money, it's fake money that you can use to play around with the system. So let me present my phone so you can see what I will do. So can you see my phone? I will do it a bit, I'll make it a bit bigger, I think. Is this okay? Okay, so I will go to the wallet. And this will, I will actually just, wait a minute, I will reset the wallet so we start from new. But in the meanwhile, I will go to the demo bank. So let's wait. So here we have we will create a new user in the bank, in the test bank. And a password. So now we have some free money that we can use to test. So now I will withdraw some of it to my wallet, like let's say 50, and continue. So now there's this QR code that I will scan. I will scan with my phone. So now we go to my phone. I can confirm the withdrawal. I accept the terms of service, and then so sorry if it's in German. So I will confirm the payment, but I actually need to do it from my browser, from this browser, because that's where I'm logged in. So I transfer the money. So from now I have the money in my phone. So now, here, if we go back, here I have the money in my phone. I have 50 test kudos. So now we will pay for an article in the demo, test, shop.test.taler.net. Here we have this demo shop where you can buy articles from the Richard Stallman's book, Free Software, Free Society. You can buy chapters. So let's buy a chapter. So pay to read more. So yes, we have the QR code for that I will use to. So I scan the QR code. So now if we go to the wallet, I have two choices. I have the choice where I can pay the single article, and I have the choice where I can pay 1 month of access. So I will pay 1 month of access. And if we go to the browser, we already have the article like immediately. It's very fast. It's very, very fast, and it's supposed to be scalable and support a lot of transactions at the same time. It's not like Bitcoin or anything. So now what happens if I want another article? So yeah, I will buy another article. So I will go to I need to scan it. So I scan it from the wallet. And the article will show. It doesn't even allow me to, doesn't even ask me for confirmation. It just shows the article because I already have the monthly subscription. And there's one subscription per language. So if you want to test different subscriptions, you can change the language, and then you will have different token families that stored in your wallet, different tokens that you will use. So it's something that it might seem a bit simple right now, but that's because that's only the surface of what can be achieved with this model of tokens. Because you can also, for example, donation tax receipts, which are for so if you want to pay your donate to an organization, but you want to have those taxes deduced from your tax payroll, you will you can get from the merchant those tickets to present to your tax authority, so that you can deduce without knowing what you donated to. And the donators, the organization doesn't know who donated to that, so it's kind of. There's also the auto-spend discount tokens and user configure merchants, regenerations, the things that I already explained, some garbage collections, and some listing management, which are still pending things. So that was pretty much it. There's much more possible, and of course, all of this is in some of the features that I presented here. Some of the features here are coming soon. Some of them are already planned. So you can have the company assets and do e-voting with voting tokens and much more. So it depends on the semantics that you define, and the semantics can be unlimited. So that's pretty much it when it goes to demo and when it comes to the. So yep. So everything is free software. So you can find the free software on our Git repositories. You are also welcome to contribute as part of the NGI initiative. So we are being funded by NGI, the Next Generation Internet, an initiative from the European Commission. So and NLNet, which is the one that is helping us get that funding. So there are some calls that you can. So they every 2 months or something. 2 months. Okay, every 2 months there are some initiatives where you can propose a call. You can propose something that you want to develop to contribute to Taler, and they will finance your contributions. So you're welcome to participate. There's more information on the NGI Taler homepage. And also, if you find bugs, there's the bug tracker. There's tutorials, there's documentation, everything is out there. And yes, this is the funding acknowledgement. And if you want the slides, you can get them from there. They're on our Git repositories. And licensing. And that's pretty much it. I hope you enjoyed my talk.
Thank you, Ivan. Can we rewind that back to the QR code?
Oh, sure.
So that people can get it?
Sure. Here's a QR code.
There you go. Get the slide. Everyone get the slides.
Yeah.
Actually, you know what? I'm going to get
They're free.
Let's see now. So, do we have questions?
Okay.
We've got a while for questions here. 1, 2. Do we have any questions from the internet?
Here's a question.
Okay, we'll start here and work our way backwards.
I'm not sure if this, first of all, very nice talk.
Thank you.
Great product. I'm not sure if this is a wallet question, but when you spend a coin, you get back what's left. How does GNU Taler avoid double spending? There must be some collaboration between the wallet and GNU Taler, but how is that done?
So double spending. So basically, the exchange has a database on all the spent coins. So whenever you get the coin back from the merchant, so it does the deposit into the bank account, it will invalidate that token. So you have no double spending because you're reliant on the exchange. So for tokens, this entity is the merchant, which is the one doing the invalidations of the paid tokens that we're used to pay. So you cannot do double spending of tokens unless you're a different shop accepting the same tokens, and you want to accept the same discounts as the competition, so that's kind of valid also. But then, it's okay.
So you mentioned taxes there. Typically, if I fill my taxes, if I run a business and I buy some software that I run my business with, on my tax form or whatever, I say something like I bought this and this from this and that. And the tax authority reads it and it's reasonable, and it's like, yeah, I can see it, you use this software for your business. In this case, what exactly can I tell to the tax officer? I bought something from someone, but it's all completely anonymous, sorry, but I spent $100.
So here the idea behind this model of donations tax receipts is that there's a collaborations with the tax authority and the organizations who are accepting the donations via Taler. So the merchant, the tax authority will issue the donation receipts that the merchant can give to the users, so that the users can do the deductions from your taxes. So that's the model. That's how it works. It will work because right now we're not deploying this yet. Okay, thank you. Yep.
What isn't super clear to me is when you make a payment, is that registered in any ledger, or are we just changing signed the tokens and the attestations? There's no intermediary.
Yeah, I mean, there's the exchange is the one having the control over the spent tokens and spent coins, because and the merchant of the spent tokens. So it has a database with all the coins that it has issued, and then it can just invalidate the ones that were used to spend. But you don't have any public ledger, any federation between exchanges. So just it's the same exchange issue and then getting them back. So that's how it works. Same with tokens. So it's the same merchant that has the database of the tokens that were issued.
Okay, do we have any more questions? You have another question? Yeah. Oh. Give me a moment. You just have to come. Oh dear.
Yeah, sure. We can talk. Yeah.
Fine, thank you. So, does it require one central exchange, or can the merchant and the buyer use different exchanges?
The merchant can accept multiple exchanges for a payment. Yes, you can have multiple bank accounts on each exchange. So typically, there will be a certain standard exchanges that the people will already have, probably. So that's the model. Yes, you can merchant accepts any amount, and the wallet needs to negotiate which ones are in common.
Okay, so we don't seem to have any questions from the internet. Do we have any more questions from the room? Stunned silence. Well, Iván, I think you've answered all of their all the questions that they could come up with. Impressive. Yeah, brilliant. Big round of applause, please, for Iván.
Okay.